Okay, we'll try again. I've been having all sorts of problems trying to start this video with everybody crashing. I have a new computer, but with the original software, and oh, I'm up here. Hi. And everything's been crashing, and trying again. It looks like I've lost one of my cameras, which is unfortunate. It seems to be running hot, and it keeps shutting down. Where are we? There it is there. I've had it for a while, and it's always worked fine with the old computer. Did I mention I have a new computer? Whoopie-doo. Okay, I have a project that I've already started, and I'm partway through it, and I just realized that it might be something that people might enjoy watching. Pardon me if I'm looking at the monitor instead of looking at you. The camera that failed used to sit over top of the monitor, and I could look at myself and see how things were progressing and whatever. Okay, this project is happening because I have lost, or we have lost in the area, our last AM broadcasting station. We're living in a bit of a null area, and we don't get much from southern Ontario, if anything at all. Even with my long wire antenna, pick up next to nothing. So our last station that was in Owen Sound has switched over to FM. Boo! And so we have nothing. Meanwhile, I have radios to service, and I have my own selection of AM shortwave radios that I now can pick up nothing. So I am endeavoring to make a little transmitter, and I'll show you what I'm using. Let me just, I can't switch cameras because I've only got one camera. So let me switch down. All right, so this is a donor radio, and this is the cabinet, okay? And what it is an RCA Victor radio, Little Master 111A, okay? It's the standard 5-tube octal AM super heterodyne radio, okay? And it's no great loss. As a radio. Again, what good is it if I can't listen to anything on it? All right, the lineup for these radios of this circa late 40s, I guess early 50s, is 35Z5 rectifier and 50L6 power output tube. And what is this? Let's go in order. This is your detector and first audio tube, which is a 12SQ7, and then you have the 12SK7, which is your IF amplifier, and lastly, or maybe I should have started with that, firstly is the 12SA7, which is the pentagrid converter. So it's an oscillator and a converter tube built into one. All right, so let me switch this down, and don't anybody get seasick with what I'm doing here, but I have to move things along. All right, this is the schematic for it, and I've got this sort of, there we go. Now people don't have to turn their head. Okay, rectifier. Okay, I'm laughing because I've got this thing reversed. Let me switch this right around. And it still is reversed. How the heck is this happening? Yeah. That's odd. So no matter which way I turn it, the image is reversed. I don't get that. Okay, I guess it doesn't really matter for the purposes of what I'm doing. At any rate, this is the 5-tube setup. No, I can't do that. Hold on a second. Okay, I corrected that. I have no idea that flip horizontally was a default setting, which is really kind of weird on this program. Okay, now, now I can continue. This is a schematic, pardon me, that's been around on the internet for some time, and I've wanted to build it. Now, this is based on a miniature set of tubes. Okay, the rectifier 35W4, as you can see, 50C5 power amplifier, and the 12SA7, which is the pentagrid, and the 12AV6. Okay, so as I showed, the tube lineup is all octal, and so therefore, in my head, which is probably not a good idea, I've been making corrections and writing them down. Where have I written them down? I don't know. It gets a bit complicated, and I'll probably have a problem. Okay, so let me back this up a bit. Okay, now, because this is the octal, all right, so instead of 35W4, we've got 35Z5, etc., etc. I mean, I think anybody watching these videos understands that. And this is the chassis. I've already started pulling things apart. All right. I've taken out almost everything. Well, I have taken out everything. The rectifier socket will be used. The audio amplifier and detector will be used. The 50L6, that's bent over, pardon me. What's that used for? Power amplifier will be used. Now, in the original setup from the RCA super heterotone receiver, this was the 12SK7, and it's the IF amp, and then the converter was up here. So I've cleaned out all of this stuff already, and I am going to use this socket as the 12SA7 converter used in this circuit right here. The IF transformers are still in place. I think I'll leave them. All right, now the next thing of concern is that this is a standard 5-tube AC/DC set. And that means that there's no power transformer, and it runs a certain risk. Now, definitely, when I would be running a signal in through here, this one anticipates by using a coupling capacitor or bypass capacitor, whatever, to the ground, or to the actual B minus, which comes in there. I don't find that's going to be acceptable for me, and fortunately for me, and look at the size of this monster. I have no idea how long I've had this, but it is marked as being 100 volts center tap at a half amp. So I'm going to use this as an isolation transformer. Now, the good thing is 100 volts is a little low, considering that this was designed to run on 115, 120 volts. However, this is so old that it's marked at 115 volts input, and we haven't had 115 volts in southern Ontario for quite some time. We're now running at 120. So now, with this running at 120 input, I've measured already the secondary AC output, and it's about 110 unloaded. I'm hoping and I'm thinking that that should be enough. Now, when it comes to the filament, if you do simple addition, if you take the rectifier, which is 35 volts, where are we? 35 volts. And filament-wise, you add the 50L6, so that's 35 and 50, 85. You add the amplifier, which is a 12 SQ7, so that's 97. And then you add the converter, which is another 12, and it's actually 12.6. What did I say, 107? So that's 117. No, did I do that right? Oh, good God, I don't know. 50, 85, 97, 109, and add the 2.6, so it's 110 in that. So if it's running at 110, I don't need to do anything about the filament other than leave them hooked up in series. Okay. Now the B plus might be a little low. I'm hoping that it'll be okay. If not, I can substitute a solid state rectifier, which should be a little more efficient than the tube rectifier, or I could even go a little weird and do a voltage doubler and then subsequently reduce the voltage through whatever to run that. I'm hoping I don't have to get that complicated. Now, the one thing that I did keep is the critical oscillator coil. Now, everything's, and of course the tuning capacitor. So the requirements according to this is the oscillator coil just has to have two windings, primary and secondary, and the way it's hooked up has to be reversed. So I'll hook up the tuning gang, which is, I think it's about 370 micro or picofarad capacitance at full capacitance. So that should work for that. Don't need the trimmer. I'll leave it. Well, it doesn't matter at this point right now. So I've got this to be used. I have to add the modulation adjust, I guess, a 1K trim pot or some kind of a potentiometer bypass. So I just need to populate this. I've got a, let's get this in frame. I have a 75, no, it's a little higher, about an 80 microhenry coil, and away I go with that. And the antenna, I have no idea how big the antenna is. This is basically going to be just to get me going so I can A, repair radios and tune off the air, so to speak, and B, listen to some of my old AM broadcast radios. But this is tube and it's going to consume a lot of power. Now what I have, to get slightly sidetracked here, is another schematic, and this I've taken off the internet, and there's various people to thank for that, and I really can't think of their names right now. But this is consisted of an oscillator and a preamp and your modulator and output. So it's 1, 2, 3, 4 transistor, commonly held transistors. I've got lots of these around. And coils and that I can sort of cobble together. Now, the one thing I don't have, because this is a broadcast band crystal-driven oscillator, trying to find something in the broadcast band, and generally what you would find is 1 megahertz, which is like 1,000 kilohertz. And I cannot find them for love nor money. Now, there's a few around. They're hugely expensive. You get yourself into the megahertz range for other purposes, and they're just about a dime a dozen. But these things are going to cost me some serious money. I cannot find them in surplus. I cannot find them anywhere. I have some on the jobber, and I'm going to consider paying big bucks. It's like, and I want to have a couple of them, so that if I want to build a second one for another portion of the house, I can. They're $17 to $20 each, and they are, and then shipping and tax and all that stuff. So it's going to be an expensive thing. But I don't have much choice. I'm too set in my ways to give up on AM, and I've got a half a dozen of my own radios that I would like to listen to. And I don't really mind jumping the queue or substituting. I can feed my old tablet with the music that I've either downloaded or have on the hard drive that I can play, and I can just feed the output in from the headphone output into here, and away I go. So that's what I want to do basically, and then I can leave this running sort of 24/7, and it won't really break the bank as far as hydroelectricity usage. So that's coming down. I've been wanting to do this for a long time, and I'm finally getting into it. Our local radio station finally gave up the ghost for AM broadcasting at the end of October, I think is what it was. Very sad to see that go. I'm sure a lot of people couldn't care less that there's no AM signal on it, but there are a few diehards like me that are. So, okay, so we'll get back to this, and this is kind of a clean chassis once you get all the other extraneous garbage out, and this may work out okay. Again, I don't want to leave it running too long. So I've got it populated to a certain degree. The old filter gang, which was huge, was over here, is gone, and there's the input filter, and then the filter for after the resistance dropping. Where's the schematic? Okay. There's the input filter, and it calls for a 50 mic, but when I look up the specs on 35Z5, it says no more than 40, and I was going to use 68, but I've dropped it down to what I had there. And then because there's a resistor going in there, I've upped this one to, I think it's 100 mic. Yep, it's sitting there looking at me right now. It's 100 mic, and that should be okay. Now you'll see that in my anxiousness to get things going, it calls for 2 watts and 2 watts resistors. I don't have them in that power range, so I've cobbled together a pair of double what I need resistors and give them space to radiate their heat. I'm not sure exactly how much they'll heat up, but I'm using that just to get things going. If it bothers me later on, I'll order the right values in the correct power range. So I'm just ready to get going on populating the converter. So your audio will be managed by this volume control. That's pretty standard for them. And the output of that will go to the preamp tube, if you like, the 12SQ7. Then it will go to the converter, the Pentagrid 12SA7, and then once that's tuned to the frequency you want, the output will be coupled to this, and then this will be coupled out to an antenna of some kind. I have a feeling that this is going to be low powered enough that I'll probably need 8 or 9 feet of wire to run it. There's a little wrinkle here that I really can't explain precisely what it does. It requires a 12AL5. I don't have any 12AL5s, and I'm unwilling to order one. So I am going to use some diodes, Schottky if they work, anything I've got, just to see what it goes. And what it does is it gives a feedback back into your cathode, and it is to reduce distortion to some degree. And I can't really say that I understand that function particularly, but I will wire up 2 diodes in there and see how that works. If I have to, I will an equivalent for 12AL5 would be an octal. I'm 6H6, so it'd be a 12H6. I'll bet you they're impossible to find. I could drill a hole and mount a 7-pin miniature socket and acquire 12AL5, but I'm hoping like heck that that will work. So what I'm going to do now is turn off the video and populate this a little more. And I don't think I need to show my hands going all over the place here while I'm soldering in components. We'll just get it done, and then I'll come back and show you. Hopefully it works, so keep your fingers crossed for me. I'm not at all sure that it will. More complications than enough. Okay, so this is part one of this whole thing, so thank you for watching, and have a good rest of the day, and keep warm. Hello, I'm back again. I've made some progress with this dog's breakfast here. This is this converted RCA mantle radio into a broadcast transmitter. And I've had some interesting times trying to get this thing going. Where's my schematic? Let me just show you the silly things that I've done here. Okay, so what I had when I first got it going is the these are miniature tubes, but I'm using octals. So I have a 35Z5 and a 50L6, 12SA7, and a 12SQ7. Okay. Now they added up with a small resistor to get the filaments lined up to 120. But then I had this wonderful idea, which turned out to be an interesting experiment. Okay, so the transformer that I'm using is this one that I've had sitting around for probably 20 or 30 years. What I intended to use it for, I have no idea. So this is what I came up with. The output is supposed to be 100 volts with a center tap at 50 volts. Now, because the transformer was originally wound for 115 or 117 volts, now that our line voltage is up to 120, I'm getting 110 from one end to the other with 55 volts AC on the center tap. So I thought, gee, how can I use this for better use? I know I want this isolated from the line. There's no way I'm going to do that. So I got rid of the 35Z5, so that's now out of the circuit, and I used a silicon rectifier with a 47, I think it's 47 microfarad, and I end up with 138 volts DC, which is a lot higher than the 35Z5. And I found out on the tube manual that there's an approximate 18 volt drop across a 35Z5. So that accounts for the approximately 110 volts I was getting with the 35Z5 and with the silicon up to there. Now, with the silicon diode used in place of the 35Z5, I now have a big deficit in voltages for the filaments. And when you add a 50L6 and a 12SQ7 and a 12SA7, which is the three tubes that will end up in this, you end up with 75.2 volts necessary to run them. Now, the resistor to drop 120 to 75 would be big. I haven't got the calculation here, and the heat it would produce and the wattage needed. I really didn't want that. So I'm thinking, how can I use this 55 volts AC? So I went, okay, I'm going to rectify it and filter it. I've got a story about that at any rate. So I have a filter cap here. Okay, and that gives me 62 volts. So I originally ran the 50L6, and its requirements for the 3 tubes is 75.2, and that's really not good. It did function, but it was loaded with distortion and it was weak. So I'm going, what am I going to do? Do I have to take a dropping resistor from here or from here to drop it down to that? And I really didn't want to do that. And then I went away, which is sometimes a good thing to do, and had to think about it. And I'm going, well, what the heck? I don't need this. I've got, I think I have, but in fact I did have a 35 L6. So when you add that up, 35.0, 12.6, and 12.6, you get 60.2. And my rectified and filtered DC for the filaments from this center tap is 62 volts. So right now I'm running it hot by 2 volts, which isn't a big deal, but I could put in a small power resistor to get rid of that approximately 2 volts in there. So this is what I did. I found a 35L6 and put it in, and it's working. Now, for the fun that I had, totally screwed up here, this is what's left of the filter capacitor. It went boom, big time. And it's here where it did. And what happened was I thought I had grabbed a 100 volt capacitor, where in fact I can't even find the sleeve that went around it. Boy, this thing launched like a rocket. It's 50 volts, and without having the actual wrapper, I had to guesstimate. But I went to my parts bin and I come up with one that is at 50 volts. In fact, everything I have of high value like that is all at 50 volts. No 100s. So that scared me. A lot of smoke. Boom, everything everywhere. And I go, oh, Lord. So what I did, it's overkill, because I either have 50 volt or I have 450 volt. So I've got this huge 450 volt capacitor, which is really overkill, which is running this. There it is there. So I've subsequently been experimenting with how to radiate the signal out, and I've used old loop antennas and various lengths of wire. I even used this, which is my, if I can get this here, this is my antenna array that works reasonably well. As a broadcast antenna, it doesn't work well at all. So, at any rate, I've got this thing running. No, there, I've lost my... Okay, it's been on now for a little while. It draws 22.8 watts according to my display. And I'm waiting for the... Here's the radio, old Philips. I'm waiting for music to come on. Of course, now when I need it, it won't. I can only play it for so long, but...
The packing, we'll handle the accommodations. The new Classical FM wants to send you on your dream vacation
And
to the
there
breathtaking island of
is
Curacao. Visit our website to enter online today.
reasonable,
and you and a guest could
and it
receive 7
depends
nights of
on
all-inclusive luxury. Make yourself
how
at home
well
at
I
the breathtaking Dreams
couple
Curacao
that
Resort.
to the
You can explore
AM
the lush.
antenna, which is inside this. It's a loopstick antenna in this case. So for purposes of testing my radios, repair radios that I get from time to time, this will do. I'll put it in the box and put it up somewhere, and then I'll run a big loop of wire around the shop, and that should give me my signal. And that'll do for that. But I'm really looking to build a solid state one, which will consume a lot less power and hopefully radiate a little bit better. I've got a couple of designs that I've seen online, and they are promising. The problem is that most of them run with a 1 megahertz crystal, and to operate it at 1,000 kcs, which is the same thing. So that serves as the basic oscillator of this solid-state transmitter. Unfortunately, I cannot find any, not one, crystal. Now I can find these TTL, I think that's what they're called, oscillators around, which give you a square wave or a sawtooth wave, and apparently they will work for this. I'll have to try that and see. Otherwise, I'll have to concoct a free-running oscillator, one that's LC tuned, and I've got a circuit for that. Unfortunately, I don't have the coil. That's required a 3.3 microhenry coil, and I haven't got that, so I'll have to dig around and order those things. So I've got some music up here. I can play just a bit. So it's not bad. It's not the cleanest, and it isn't the brightest. In other words, the high end is really missing. I've made some modifications, pardon me, to try and pre-emphasize the high end for it, and it's moderately improving it. So this is what I got. It was an experiment. Oh, I have to explain something in my addled brain. Somewhere, if I can get this down, this transformer is the oscillator coil, and in the case of this radio, it's right there. So it's the original oscillator coil that came with the radio. And let me see if I can turn off the lights and remove some of that glare. So somewhere I got the information that that's my writing there. It says L winding, which means low side. So I hooked that up as per, which means this side goes from the cathode through this modulation adjustment trimmer pot to ground, and then the grid number 1 hooks up to this side. Didn't work, didn't oscillate, didn't do anything, and I'm driving myself crazy. And this is the second attempt. I did make one from scratch, and I was thinking that my coils were not suitable for this. And then again, I went away and I thought, maybe this is incorrect. Maybe it should be the other way. So the high winding, which is about 8 ohms DC as opposed to 1.5 ohms DC, maybe I had them reversed, and this information is incorrect. So I swapped it over, and where are we? You can see there's the coil, and there's the, oops, let's get that up there. There's the adjustment for modulation, the coil, and there's the 12SA7, and that goes to the cathode, and then the the tuning capacitor's there, and that goes there, and I hooked it around the other way, and it worked. Oh my goodness. All the fun and games that I've had with this thing, and it actually worked. So it does work, and it is what it is, and it saves this chassis from going into the garbage, because I'm trying to get rid of a lot of stuff, get them sold or get them thrown or get them repurposed. So the other comment that I'd like to make is that from the original website, it said that a 12BE6 will be, it's a remote cutoff pentagrid, and it causes distortion. So it's best to use a 12CS6. And while I can find 6 CS6s, I cannot find 12. And again, I'm using octal base, and this is miniature base. Oops, the 12BE6 or 12SC6 is miniature based. And so I would have to make an adapter to put it in there, and I'm going, I'm not going to bother. This works enough to test radios that I might have in for repair, to get decent performance out of the consoles and other radios that I have that are AM only. I will try and build this AM solid state unit. So this is a wrap for this. I'm just going to put it in the box and mount the transformer on the spare where the speaker went, and put things back into semblance and get on with things I have to do on my bench. So at any rate, I hope this was some sort of interest to people who are watching, and I do thank you for watching, and I wish you a good day and a speedy spring, please. Thanks. Take care.